who invented recurrent neural networks. Have you ever wondered how machines can remember information over time? This is where recurrent neural networks come into play. So, who is behind this fascinating technology? The story of recurrent neural networks, often referred to as RNNs, is not about one person but rather a journey of many researchers over several decades. The concept of RNNs has roots that go back to the mid-20th century. In 1943, Warren, McCulloch, and Walter Pitts laid some of the early groundwork. They explored networks with feedback loops that could retain information. Their work was foundational in understanding how networks could function similarly to the human brain. Fast forward to 1960, and we meet Frank Rosenblatt. He introduced the idea of closed-loop cross-coupled perceptrons. These had recurrent connections and used a learning rule inspired by how biological neurons work. This was a significant step toward creating networks that could learn over time. In the early 1970s, Shun'ichi Amari made further contributions by proposing changes to how recurrent network weights were adjusted using the same learning principles. His work helped shape models that could remember information in a more sophisticated way. Then came John Hopfield in 1982, who popularized what we now call the Hopfield network. This network model used recurrent connections to create associative memory, which is crucial for tasks that requiring recalling information. The evolution of RNNs continued with the introduction of specific architectures in the late 1980s and early 1990s. The Jordan network, introduced in 1986, and the Elman network, introduced in 1990, were designed to process sequences effectively. These networks helped pave the way for more advanced applications. A major leap occurred in 1997 when Sepp, Hochreiter, and Jürgen Schmidhuber invented the long short-term memory network. This specialized architecture was designed to solve the problem of learning long-range dependencies in sequences. Long short-term memory networks have since become essential in many artificial intelligence applications, especially those involving sequential data. From an artificial intelligence and machine learning perspective, RNNs are vital for tasks like natural language processing, speech recognition, and time series prediction. They are the backbone of models like Chat Generative Pre-trained Transformer, which processes text sequences and generates human-like language. Understanding the history of RNNs helps us appreciate the technical challenges and ethical considerations in designing artificial intelligence systems that handle information over time. Issues like bias and interpretability are important as we continue to develop these technologies. The journey of recurrent neural networks is a testament to the collaborative efforts of many researchers who have shaped the field of artificial intelligence.